So here's the Raspberry Pi on the screen, and I want to show you the piece of code I made. You can see you import some of these libraries and then define your globals and some variables here and there, and then you set up the inputs and outputs, then all your functions. So a clear screen function, value limiter, read your pot meter inputs, and you can see here I have bit banged it, because otherwise you could use this SPI def. It's a very useful, shorter piece of code, maybe faster, but in order to make it work together with the digital pot meter, I had to use bit bang methods, because this one does not work. The pot meter does not work with the SPI def because it has a 3-pin output. Yeah, and so there's no way to set that. There's this option called 3-wire, but it doesn't work. So that's why it works this way. Also, you can see this LED right here. There's a piece of code for that too. Then there's read inputs like reading the pot meter, so this refers to the function above. The switch is being selected here, so there's 6 wires, and once one is active, then it makes that the status of the switch. So then you actually see the function of the programs. So all of the functions that are behind this pot meter are done here. So all of these values are put down from 12 bits to 0 to 100%. And then you have the actual program which makes the output. So all of these pot meter values, let's just call them that, they're being read into here, and then it selects which wave is being used, and then it creates this calculation which makes that particular wave. And for random, it selects either of these waves for a short period of time, which is pretty random. So you can see here it selects this random wave or that random wave, and then it just outputs this for a little bit, and then it has an off time. And so this is the actual main program. That's quite clean because you have all these functions above here, so you don't have to have all these codes down here. So first you have inputs, then calculations, and then outputs, and that's it. So I'll still have to make presets, for example, and organize the code a bit here and there to make it smooth, nice. Otherwise, that's it. So let's see this code in action actually, and then I'll make it view what the actual pot meter value is coming out of the thing. So you can see it started at 0. And then I can modify it from 0 to 128. Because this pot meter doesn't have that extreme high resolution, I don't know why. But I don't really care. Because it works. So, and then when I press the foot switch, I can select the baseline and its deviation. So let's select the mode. Here you can see it's moving up and down linearly, and this is also linear but falling saw wave, and this would be the rising saw wave. I'm guessing this is the tangential wave. You can see really fast changes from up to down and then keeps it up or down there. This will be the square wave. You can see it modulates between 27 and 22. Obviously you can change those settings, but I'm going through the modes now. So, and here we have the sine wave. Alright, so this is not actually a proper representation of it. I have to move the baseline slightly. You can see it's a pure sine. And then the glitch processor. So yeah, it just does total random stuff here. Here and there you see a glitch. So I hope you enjoyed this video, and thanks for watching.